Hi, this is Jeremy Brighton with Core Software Solutions. Today I'll be walking you through a new application I finished up writing for essentially allowing people to write their own code on an iPad device. Now the language is limited. It's the coreBasic programming language, which is similar to basic syntax. It's a linear programming concept. So the idea is that there aren't function calls, but you can do gotos and labels. The other aspect of the language is that it's very simple to learn, but it's feature-rich. It is a Turing-complete language, so you can write whatever you want to, and the outputs are actually pretty advanced. The outputs, if I zoom in down here, in the middle we could see a text box that's kind of like your console for the application. Everything that's bold is the output from the application, while the input is always written in light lettering. So if I write hello world, the application, when I'm running it, will actually read it. On the right side is a debugging system, which I have not yet implemented, but it shows the locals of the variables. As well as on the left side is a 92 by 68 pixel screen. I'm actually trying to model the interface off of the TI Basic, which is a graphing calculator programming language, which I found really useful when I was trying to learn how to program myself. So anyways, if we go back to the root application, you'll see that there's a little browser system. There's files on the right and then folders on the left. You could also click an information button to learn a little bit more about the language and examples to do that. So let's go back here. There's standard features. We could go ahead and delete a file if we want to by long pressing it, or we could go ahead and create a new file. We could call this main.cb. CB is the file extension for coreBasic source code. We could hit continue, open it up. We could go ahead and hit run. Now if we scroll down, you'll see that on the text output it wrote hello world, just like we wrote in our application. Let's do something a little bit more interesting. So let's do a for loop for the variable I from 1 to 10 inclusive, and it iterates by 1 each loop. You'll notice that I hit enter here, but instead of doing a straight new line, the application knew that I was starting a new block of code and went ahead and tabbed me. So let me display I, then let me display a new line, and then let me end the block. You'll also notice again when I hit end and I press returns, it reformatted it to the left correctly. Also, overall, the code does have syntax highlighting, though I'll have to set up a menu or some sort of configuration system to allow users to change that. So if I scroll down here, hit the run button, you'll notice that, bam, on the console we got 1, 2, 3, 4, 5, etc. We could run it again. Right now, the application goes ahead and compiles this coreBasic language into a sort of bytecode, which is then executed in a pseudo virtual machine. I like to call it a virtual machine because it does attempt to map out each instruction that is generated from coreBasic onto an operator that is very primitive, so very quick to execute by the host operating system. Also, you'll notice that if I were to put a mistake, so let's say an undefined keyword here, or we'll start something without a block, or we'll start a block without something, it still attempts to understand best what you're trying to do. I'm still in the process of figuring out whether or not I want this language to be very strict, meaning if there is an issue it just crashes, or if I want it to be lenient since it is an educational environment where I want it to go ahead and just be quiet about the errors. For example, Objective-C is very good about handling errors. If you instantiate an object and it fails, it'll set itself sometimes as nil, and that'll allow you to silence a couple of warnings and help out the user experience. The problem with that, though, is as a developer, it's sometimes a really nasty bug to track down. So part of this application, and again, this is just the first version, you can go into the challenges directory and choose a challenge. And what I'm going to have set up is I'll have more of these challenges where it explains on the very top the kind of challenge, the difficulty, what you're supposed to do, as well as it gives you starter code. But in the end, if you're actually able to run this and execute the output, meaning if you can match it with what the program should give you correctly, then you'll get some sort of achievement, or the user just gets a little flag on that file demonstrating that they finished it. So there's a couple of also examples associated with a project. A simple one is this, where we're just displaying text information. So it's very similar to a while loop. Actually, it's even more similar to a for loop, but we're only using labels and go-tos, and it's really to help emphasize the educational aspect of the application to really help people understand that, for loops might look complicated, but all they are just simplified labels and go-tos with conditionals. So we could run the code, and again, it prints out 1 through 10. There's a dozen other examples. Just as an example to deal with user input, let me run this application. On the console, it says how many times you want me to loop. Let's do something fun, like 100. So we press enter, and bam, it's starting to iterate through. Now you'll notice also the application isn't lightning fast, even though I can make it. The reason why is that the main thread, who's actually doing the simulation, I only set at 100 hertz, so it's updating or executing one instruction every 100th second, every 1/100th of a second. If we want to, we could go ahead and use that or move that to a maximum. I might allow the user to play with that value. I just chose 1/1000th to go ahead and choose a fine balance between output speeds and then also battery life. I've yet to install this on my iPad myself, but I will release the source code or at least some sort of preview application with this video. So thanks for watching. Bye.